Hello guys, this is Prime Concept. Now in this video, we want to analyze equation of a straight line. We want to look at the equation of a straight line. If we are given a straight line or we are given some points that would form a straight line, how do we find the equation of any line, right? So that is what we want to consider in this video. One of the things we need to know is that for you to be able to get the equation of any straight line, you would need to know the slope, which is also known as gradient of a straight line. So it means we're going to start from learning how to find the slope or gradient of a straight line. So we want to consider gradient or slope, which is denoted by the symbol m. So we want to learn how we can find the slope of a straight line. Now let's say we have a straight line with an arbitrary point. Let's say A, this is x1 and y1. Then we'll have point B that has coordinates x2 and y2. Now, this is a straight line and we want to be able to find the slope of this straight line, right? If I extend this straight line, extend it, because it would make an angle with the x-axis, right? This angle which is called theta. And this is point A actually. So that if I construct a triangle from this point A, if I construct a right angle triangle, you will also notice that this angle is also going to be what? Theta, alright? Now what's the reason why both of them would be equal? Because both of them are corresponding angles and corresponding angles are always equal. So if this is theta, this should also be theta, right? Now let's get this length. If this point, this height at this point you have y2, it means that at this lower point you have y1. So that this height is going to be y2 minus y1. Similarly, for the x-axis, if at this point you have x2, at this point you have x1, then this distance is going to be x2 minus x1. So that if we want to find the gradient, the tangent of the angle theta, we're going to have that tan theta. Remember from your SOHCAHTOA, tan simply means opposite over adjacent. So tan theta would be opposite, which is this, over adjacent. So tan theta would be y2 minus y1 all divided by x2 minus x1. So what we have gotten, which can still be written, we can still write this as tan theta. We can still say y1 minus y2 divided by x1 minus x2. It will still be correct because if you just factorize, you'll notice this would give you the same result, right? So that you would note that tan theta is equal to what? M, which is the slope or gradient of a straight line. So you want to find slope of a straight line. What would you simply use? You're simply going to use any of these equations. So which simply means that M, which is gradient, is going to be y2 minus y1 divided by x2 minus x1. So this is how you can find the gradient or the slope of a straight line, right? So the slope of a straight line is same thing as the tangent of the angle the straight line makes with the positive x-axis, right? Now, I would want you to also notice that slope is not necessarily going to always be positive. So slope can also be what? Negative. So the slope of a straight line can be a positive quantity. It can also be a what? A negative quantity. So in this case, we considered when the angle here is acute, which simply means your slope would always be positive, right? Then you can still have a case where your straight line would be in this form. In that case, your angle will be obtuse, which would make your slope to be negative. But generally, this is the formula for finding slope of a straight line. So whether positive or negative, with this formula, we can always find the slope of a straight line. So let's take a simple example. Now say we have a straight line given by 2 points. So find the slope of a line given by A 2, 3 and B, let's say -1, 4. So find the slope of a straight line given by these 2 points, right? So we want to simply get the slope, knowing that if I call this x1, then I should call this y1. If I call this x2, I should call this y2. I can also do the reverse. I can still call this x2 and call this y2, then x1, y1, right? To give you the same result. So your slope, m, using this relationship, is going to be y2, which is 4, minus y1, which is 3, all divided by x2, which is -1, minus our x1, which is what? 2. So this would give me 4 minus 3 is 1. -1 minus 2 is -3. So you can see that in this case, my slope is what? Negative 1/3. Right? So which means that the angle is actually going to be what type of angle? An obtuse angle. So this is our slope. I believe this is clear. Now we want to further this. Since we have learned the concept of slope, the next thing is we want to jump straight into how we can find equation of a straight line, right? Now, we have 3 different ways of finding equation of a straight line, or 3 different forms that we can use to get the equation of a straight line. So you would note that there are 3 forms for equation of a straight line. Number 1 form for equation of a straight line is what we know as the tangent form. So the equation of a straight line can be gotten in terms of tangent, right? So the tangent form is number 1. Number 2 is what we know as slope-intercept form, right? And then number 3 is what we know as the intercept form, right? So these are the different forms for which we can put the equation of a straight line, or we can use to find the equation of a straight line. So I'll be starting with the first one, which is the tangent form for equation of a straight line. Now, still considering the same kind of straight line we used initially for the tangent form. So we have a straight line given like this. We have a straight line like this. So this is a point on the straight line, point A, which has coordinates x1, y1, and then we'll have a point B, which has coordinates x, y, right? Yes. So if I construct a triangle for this again, in similar way, we construct a triangle so that this angle, which is theta, is same as this angle, which is theta, right? You will still notice that this height is going to be y, which is this, minus y1, so that this particular length, horizontal length, is going to be x minus x1, right? So if we consider the tangent again in this case, then we would have that the tangent of the angle is going to be the opposite, which is what? Y minus y1, all divided by the opposite over adjacent, which is going to be what now? X minus x1, right? Now, if you recall, we mentioned that tan theta represents what? Slope. So I can simply write that in place of this, I would have m equals y minus y1 divided by x minus x1. So that if I cross multiply, I would have, of course, you can say this is divided by 1. So if I cross multiply in this case, I would have y minus y1 equals what? M into what? X minus x1. So this is a way we can find the equation of a straight line. So we can still use this relationship. And this is also known as what? The tangent form for equation of a straight line. So I'm going to call this equation A, which is the first, the tangent form for equation of a straight line. Now I'm going to use it to solve a problem so that the concept can also be clear. And let's take this problem. Let's take a problem. So we have this problem we want to use as an example to illustrate how we can find the equation of a straight line. And the question says find the equation of the line passing through the points A and B. So what it means is that for you to be able to find the equation of the line, the first thing you want to find is your what? You are very correct. You want to find the slope. Because looking at this, you would need your m, which is your slope. So I'm going to call this point x1, call this y1, and call this point x2, call this y2. So if I have this, I'll be able to get my slope, which is m equals y2 minus y1 divided by x2 minus x1. This is how I can find my slope. So which is going to be y2. What is my y2? 3 minus, right? Then my y1 is 4, all divided by my x2, which is 4, minus my x1. And notice I'm going to use a bracket because my x1 is -2. So I'm putting a bracket, -2, so that you can simplify that work. Then your slope is going to be 3 minus 4, which is -1, divided by, now, minus multiply this minus becomes plus. So I would have 4 plus 2, which is what? 6. So my slope is actually going to be m equals -1 divided by 6. So taking it to this equation A, I'll be able to find the equation of this straight line. So remember, y is an unknown, right? But y1 is given. So we can use any of these 2 points, A or B, can serve. So let's start with point A. Now, we have y, which is unknown, right? Minus, which is the variable. So it's a variable. So you have y minus y1, which is what? 4, equals what now? Our slope is what? -1 divided by 6 into x minus x1. What is our x1? -2. So I have -2. So what do I have here? I have y minus 4 equals what now? -1 divided by 6 into x. Minus is plus this, right? So that if I rub this part so that I can complete this, I can cross multiply with 6. I can use 6 to multiply this side. So if I use 6 to multiply y, I'll have 6y. If I use 6 to multiply this, I'll have -24, right? Equals, then this -1 would open. I would have minus x. -1 would open this. I'll have -2. So that if I rearrange this, bringing x to this side and writing it first, I would have x, then plus 6y, then -24. When this crosses, it becomes +2 equal to 0, right? So I have x plus 6y. This is going to be -22 equals what? 0. And this becomes the equation of my straight line. So very simple to find and very simple to analyze. Now remember, if you had used point B rather than point A, you still arrive at this same equation. You get the same value. So you either use point A or use point B. Any one of them would give you the same result, right? So this is the equation of the straight line. Now remember, what we are using at this point is our tangent form. So since this concept is clear, we're going to move straight to the next form for equation of the straight line, which is what? What did we say? There's a second form for equation of a straight line. The second form is going to be our slope-intercept form, or you can say gradient-intercept form. That's the second form. Number 2 is slope-intercept form. So this is the second form or second way for which we can get the equation of a straight line. Now, if we carry on from the equation we already derived, which is y minus y1 equals m into what? X minus x1. If we take on from this, we're going to arrive at the slope-intercept form, right? Now, what I'm going to simply do is I have y minus y1 equals, if I expand this, it's going to give me mx, right? Then when you open this, you'll have mx1. So that when you push this to the other side, you would have y equals what now? This is here, which is mx. Then you have when y1 minus y1 crosses, it becomes plus y1. Then you have minus mx1, right? So I'm going to group this because this, everything you have here is a constant. So remember, y1 would always be known as a point. X1 is also a point, it's constant. Then the slope is a constant. So which means that every quantity inside this bracket is a constant. So I'm going to denote it with a constant C, so that I can then have set y1 minus mx1 to be what? C. So if I do that, I'll then have that y, which is this, is equal to what now? Mx plus what? C. So this is equation B. So this is another form for equation of a straight line, and we call this what? The slope-intercept form. Why do we call it slope-intercept form? Because this equation includes the slope, and then C, which is the constant here, is known as what? The intercept. So you take note, M is slope, and then C is intercept. So whenever you are given an equation and you are required to find the intercept of that equation, what you simply do is to make y the subject formula in that particular equation, then compare it to this equation. You'll be able to get your slope, you'll be able to get your intercept, right? So this is a very beautiful equation, and an equation that is applied almost everywhere, every time in engineering, in physics, right? So let's look at a very simple example. But before we consider an example, I want to mention some points you should note about slope, which are very important. So there are 2 points I want to mention that you should know about slope. One is that if you have, say this is your coordinate system, and then you have your straight line which you're trying to find the slope. Now that straight line is parallel to your x-axis. This is the straight line which is parallel to your x-axis. If the straight line is parallel to the x-axis, it simply means that the slope in this case is going to be what? 0. So when a line is parallel to the x-axis, your slope is going to be what? 0. Now, if the slope is 0, it simply means that your equation for a straight line, which is this, would now reduce to y equal, because m is now 0, would now reduce to y equals what? C. So this would now be your equation of a straight line. Whenever the straight line is parallel to the x-axis, like in this case, your slope would be 0, and then your equation becomes y equals what? C, just the intercept. So this is first point I want you to note about this. The second point I want you to note also is that if you have this now and your straight line is parallel to the y-axis, so which is something like this. This is your straight line which is parallel to your y-axis. In this case, your slope m is going to be what? You are correct, infinity, right? So the slope is going to be infinity in this case, right? Yes. So this is a point that is worthy of note, right? Yes, I believe this is clear. Now let's take a simple illustration. Okay, let me still give a third point you should note. This is 2. And number 3 point you should note is that if your intercept on the y-axis is 0, remember this C represents intercept on the y-axis, not the x-axis. So this is your y-intercept. Now, if the intercept on the y-axis is 0, that is to say, if C is equal to 0, then your equation of a straight line would reduce to y equals what now? Just mx. So what it simply means is that that straight line will pass through the origin. So this is how it would look. This is how it would look to go through the origin, since the intercept is what? 0, right? Yes. So it will go through the origin. Now let's proceed. So let's take a simple example or a simple problem to illustrate this form of equation of a straight line, right? Now say you're given the line 3x minus 4y plus 6 equals 0, comma, find the slope and intercept of the line. This is a straight line. So they gave us the equation of a straight line as this. Now they want us to find the slope and the intercept of this straight line. So very simple. We're going to relate this to this. Now I mentioned to you that whenever they give you an equation, so what you need to do is to make y the subject. When you make y the subject, you compare it to this standard form, then you find your slope and find your intercept. So let's do that. We have 3x minus 4y plus 6 equals 0. So what I'm going to do is I'm going to move minus 4y to this side. So on this side I would have 3x plus 6 equals what? 4y. So that I can rewrite this by saying 4y is equal to 3x plus 6. I hope this is clear to you. Yes. So what am I going to do to make y the subject? I'll divide through this equation by 4. So I will have divided by 4, divided by 4, divided by 4. So if I do that, this can fizzle this. I'll be left with y here, so that I can have y from here alone, right? Equals what? 3 over 4x, which is what you can see here, then plus what? 6 over 4. So this is what we have when we make y the subject. Now remember, the question says find the slope and intercept. Now if you compare these two equations, you would notice that since m represents your slope, which is attached to x, the quantity attached to x in this case is what? 3 over 4. So it means that our slope m is going to be what? 3 over 4. So we've been able to find the slope, right? Now the next thing is to find our what? Intercept. Now what is the constant part in this case? The constant part is obviously what? 6 over 4. So our intercept C is going to be 6 over 4, which you can still reduce to 3 over 2. So this is how you can apply this equation to find this, right? Now, let's say we have another kind of problem. They want us to get equation of a straight line from points, and they want to use this method. It's very simple. So you see how we solve that. So let's take another example. So let's see. Now we have this problem, right? The question says, find the equation of the line passing through the points A and B, right? Yes. Now we can use the first form, which is the tangent form, to solve. We have used it to solve a similar problem, right? But this time we want to apply the second form, which is a slope-intercept form. But one thing remains common for all this, which is the slope. So you would need to find your slope. So let's find our slope m. Remember, if I call this x1, I'll call this y1, x2, y2, right? So that my slope m is so this is my slope, right? So which is going to be y2, which is 2 minus y1, which is 4, right? Divided by x2, which is 4 minus, what is my x1? Minus 2. So that my slope becomes 2 minus 4 is minus 2, all divided by this becomes minus minus is plus. So 4 plus 2 is what? 6. So my slope is minus 1 over 3. So this is my slope. Now I want to use that form. Remember, if I'm using the form y equals mx plus c to arrive at the equation of my straight line, I need to find slope, which is what I've gotten. Then I need to find intercept. If you recall, we mentioned that the intercept C is y1 minus mx1, right? That is what we actually said. So that my y1 is going to be 4. Remember, I can still use this coordinate. It will give me the same result. So, but I just want to maintain, since I've called it y1, x1, let me use it so that I won't confuse you. So minus my slope. What is my slope? Minus 1 divided by 3. then my x1 is minus 2, right? So my intercept C is going to be 4, right? Then I have, remember, I have minus 2 times minus 1 is plus 2, right? Plus 2 times this becomes minus 2 over 3. So that if you do this LCM, you just simply say 3 times 4 is 12. 12 minus 2 is 10. So it means this is going to be 10 divided by 3. So you just say this times this, which is 12. 12 minus 2 is 10 divided by the number under. So I've gotten my intercept, so which simply means my equation from this is going to be y equals m, which we got as minus 1 by 3 x, then plus c, which is what now? 10 divided by 3. So this is my equation of a straight line. If you don't like it in this form, all you simply need to do is to multiply through by 3, the common denominator there. So if I multiply through that equation, by 3, multiply everything, I'll have 3y equals 3 would cancel this 3. So I'll be left with minus 1 times x, which is minus x. And if I multiply this by 3, 3 would cancel this, you'll be left with plus 10, right? So that you can simply say, if I bring this here, it becomes x plus 3y. When this crosses, it becomes minus 10 equals 0. So this is the equation of a straight line. Either this or this, depending on your exam. If you're writing an objective exam, they may decide to put this in the option rather than this. If you're writing a theory exam, if you stop here, you are correct. If you stop here, you are still correct, right? Now then, finally, in this particular video, we're going to look at the third form for equation of a straight line. The third form, we mentioned that the third form is what? The intercept form. The intercept, which is number 3. The intercept form. Now, what is the intercept form? Now, before we mention the intercept form, okay, let's just go straight to the intercept form. Now, let's say we have a straight line, right? That is in this form. We have a straight line like this, such that it has an intercept on the x-axis. It also has an intercept on the y-axis. Now, at this point, if the x-intercept, we call it a, it means that the coordinate of this point is going to be a, 0, right? So where a is the intercept on which axis? Our x-axis. Now, whenever a line intercepts the x-axis, it means the y-coordinate will be 0. Now, if we call our y-intercept to be b, it means that we're going to have 0, b at this point. So that whenever a line crosses your y-axis, the value of x at that point is 0. So we want to get the intercept form for equation of a straight line. Now, using these 2 points, we can use them as our coordinates to derive the equation of a straight line in the intercept form. So which would give me something like this. Remember, my equation is going to be my slope first. Let's get our slope. So using these 2 points, so if I call this x1, y1, x2, y2, my slope is going to be y2, which is b, minus y1, which is 0, all divided by what? X2, which is 0, minus x1, which is a, so that my slope becomes minus b over a. So check it very well. B minus 0 is b, 0 minus a is minus a, so my slope is minus b over this. Now, if I use my formula for finding the equation, now let's say we want to use the previous form. We want to use y, okay, y minus y1 equals m into x minus x1. So we want to use this now to find our equation. You realize that you have y minus y1. What is our y1 in this case? Our y1 is 0 equals m, and our slope is minus b over a into x minus x1. What is our x1? Our x1 is a, right? Now, if I open this, y minus 0 is y equals minus b over a times this would give me minus b over ax. Minus b over a times this would give me plus b, right? Because this a would fizzle this a, so you have plus. Minus minus is plus, so you have plus b. So that if I multiply all through this equation by a, because I don't want a to be down again, if I multiply all through this equation by a, I would have ay equals what now? Minus bx plus what? Ab, right? Yes. If I rearrange this, I want to bring this to this side, I would have bx plus what now? Ay equals what? I'll leave this here, ab. So if I do this, I would have something like this. So that if I divide through this equation by ab, I would have that bx divided by ab plus ay divided by ab would be equal to ab over what? Ab, right? Now you notice that b can fizzle this. So what would I have? I would have x divided by a plus what do I have? A would fizzle a. I would have y divided by b equals this would go equals 1. So this is the equation of a straight line in what we know as intercept form, where a is x intercept. So intercept. A is the intercept on the x-axis, which you would notice is directly under x. And then B is y-intercept. So y is B is the intercept on the y-axis, which you would notice is directly under what? B. And this summation is equal to what? 1. So this is another very important equation, which you know as intercept form for equation of a straight line. Now, let's use this to solve a problem so you will understand why this is important. So we have this problem on the board, so which relates to this form for equation of a straight line, right? So I'm going to rub this space. And the question says, find the equation of a straight line which makes intercept of minus 3 over 2 on the x-axis. So it simply means that our x-intercept, which we denoted by a, is actually minus 3 over 2. And then it makes an intercept of 7 on the y-axis. So meaning that our b, which is the y-intercept, is 7. So the question says, find the equation of the straight line. Now, using our formula, we have that x over a plus y over b is equal to what? 1. So it means I'm going to directly place a and b. I would have x over minus 3 over 2 plus y over what? 7 equals 1, right? So which these 2 under can come up to multiply x, right? Since this is division, to change it to multiplication. So you have 2x divided by minus 3 plus y over 7 equals what? 1. So that I'm going to write that equation in a better form. So what will I do now? The LCM here is what? I can say the LCM is 21. So I have 21. Now, to make it easy for you, this minus can stay anywhere to still be correct. So let me write it here so it won't confuse you. So I would say 3 in 21. What will it give me? It will give me 7. Now, 7 times minus 2 is going to be minus 14x. I'll come again. 7 in this case. Now 7 in 21 will give me 3. 3 times y will give me plus 3y. Then all will be equal to 1. So if we cross multiply here, 21 would multiply 1. So I would have minus 14x plus 3y equals 21. A better way to write this is going to be, if I take this to this side, is going to be I'll have 0 on this side. So when this crosses, it becomes 14x. When this crosses, it becomes minus 3y. Then they are going to meet this, which becomes plus 21. So we can write this by saying 14x minus 3y plus 21 equals what? 0. And this is the equation of the straight line. So I believe this concept is very clear. Now you would have noticed that when I'm solving for equation of a straight line, I always write the x before the y, right? And then our constant then equal to what? 0. So this would lead me to the final point, which is what we know as the general equation of a straight line. So generally, equation of a straight line is always written in this standard. So the general equation of a straight line, general equation of a straight line. So generally, the equation of a straight line is written as px plus qy plus r equal to what? 0. So this is the standard way of writing, another way of writing what? Equation of a straight line. So we know this as the general form for equation of a straight line, so that when you compare this to this, you can quickly see that p in this case is what? 14. Q in this place is what? Minus 3. And then R in this place is what? 21. So they can give you two equations and ask you to find the values of the constants in another equation. So what is the deal you should know about this? What you should know is that if this particular equation is proportional or is the same as this equation, still we have p prime x plus q prime y plus what now? R prime equals 0. So if these two equations represent the same straight line, or if these two equations are equation of the same straight line, then their coefficients are proportional. So what it means is that you can say that p is proportional to p prime, right? So that when you remove the proportionality, you simply say that p is going to be a constant k times p prime, right? Similarly, you would say q is a constant k times what? Q prime. You would also say r is a constant k times r prime, right? So I hope this would not be confusing. Let me give you a simple example to also buttress this point before we conclude this video. So we have this equation, this problem on the board, which is going to be related to this general equation of a straight line, right? And the question says, find the values of L and M if this straight line, if this equation Lx plus My plus 5 equals 0 represents the same straight line as this. So that is to say, these two equations are representing the same straight line. So they want us to find the values of the constant L and M. So using this idea, we mentioned that if you have two equations representing the same straight line, then their coefficients would be proportional. So what it means is that I can say that this coefficient L is proportional to, okay, remember this Lx, so you have to rearrange this, right? So rearranging this, you would have the first equation is Lx plus My plus 5 equals 0. The second one, I'm putting x first, so that I would have, I would have minus 3 minus 2x plus 3y plus 1 equals what? 0, right? Now, so if we consider this, so it simply means that L is equal to a constant k times what now? The coefficient here, which is minus 2, right? Yes. Now, we don't know what k is, but our aim is to find L. So the same way, if you compare this, it also means that 5 is equal to the constant k times this times 1. So that k times 1 is what? K. So you can simply say that k is equal to what? 5, right? So if k is 5, I can find L in this case now. I would simply say that L is going to be k, which is 5 into minus 2. So my L is going to be minus 10, right? Yes, so in the same way I can find m, knowing that m is equal to k times what? 3. Right? And I know k already. So my m is going to be k, which is 5 into 3. So my m is going to be 5 times this is what? 15. So I've been able to find L, and k. L is minus 10, and then m is 15. So just using this comparison to find it. So I believe that this concept I've explained for straight line is really very clear to you. If you are enjoying my videos and you get values from these videos, please don't forget to hit the subscribe button, like my videos, comment, and then share with 10 of your friends. Tell them this is prime concept. In my next video, I'll be explaining how, if you have maybe 2 or more straight lines intersecting, how do we analyze them? That is going to be the topic for the next video. Thanks for watching Prime Concept.